Welcome to the webcast on megatrends and their impact on your capacity needs. My name is Henrik Zangenberg, and I'm the founder of Zangenberg Analytics. And today we will go into the details on how you should look at your project portfolio and the developments facing you over the next 2 to 3 to 4 years in order to get a view of your capacity needs. Because my promise is that if you take a closer look, you'll find that you'll need a lot more capacity and probably more than you have budgeted for and more than your current prognosis will show. And we'll get into that during today's webcast. So when we're talking about megatrends, we are talking about the things that will have the biggest impact on your new development over the coming years. So what are the technological trends that will have the biggest impact? And I'm sure that most of you will think AI and machine learning when I'm saying megatrends, and obviously that is a big part of the picture, and we will go into some level of detail there. But we will take a look, a bit of a broader look of the different megatrends that we believe and others like us believe will form the future. So let's take a deeper look here. First of all, when I'm asked to speak to boards or C-level executives about digitization and IT and the future of IT, I usually start off with this to say, okay, so why should leaders and managers and board members, why should they care about IT? And basically there are 3 reasons for that. One is IT represents, and digitization represents opportunities to change the way you do things, opportunities to do things differently, do new things, and also to stop doing things or let the machine do things instead of you doing those things. And I think we are in a period right now. I'm an old man, so the period right now reminds me a little about the period just leading up to year 2000. So there's a lot of enthusiasm around. There's a lot of opportunities that we see in using new technology, especially using AI and the proliferation of ChatGPT and so on has changed the conversation a lot. So there is a lot of attention to opportunities right now. You could say there's a rush for finding out how we can utilize all these new technologies in different ways. And every sensible board member will ask their CEO, do we have a good machine learning project in place? So there's a lot of opportunities around. There's a lot of focus on the opportunities. And what will happen, as it did in the late 90s, is that there will be a surge of investments in companies. Most of your companies will most likely be investing in pursuing some of these opportunities, experimenting with these new technologies. And this will result in some successes and a lot of failures. That is basically what happens when we are in this kind of situation right now. But the successes will leave you with new systems and new requirements for capacity, for infrastructure capacity. And it's that capacity that's in our focus right now. Because the future will be expensive. The future will contain systems that will require a lot of capacity. And we will go into that. Now, the future is also, and the reason why IT leaders should care about IT is also because IT, with IT and with IT problems and with the current IT landscape, you get a lot of risk, a lot of cybersecurity risk and all other kinds of risks. And as a manager, you need to focus on also basically get a good picture of the risks and also make sure you have mitigating actions to basically contain that risk. And the risk picture and the way we mitigate risk, the way we handle cybersecurity risks is also an area that will require huge amount of infrastructure itself. And we'll get a little more into that as well, to basically see where should you look for that coming infrastructure requirements that follows from your cybersecurity initiatives. And yes, when I talk to IT, when I talk to top management about IT and digitization, I tell them that they should care about it because it's expensive. It does cost money, and it will cost a lot more money in the future. We will spend more money on IT, and the IT proportion of our total budget will increase in the future as a result of all these initiatives and as a result of the infrastructure and capacity requirements that follows from these. So this is why what I'm talking about today is of interest not only to the IT people, not only to the procurement and sourcing people, but it's of interest to top management and basically everybody in an organization. So if we are to just summarize what the future will be like, I basically put these 5 headlines in, and we will focus on basically 3 of them. But if we are to paint a picture of the future, we could say that the future is digital and it is artificially intelligent. So the future will be more and more digital. We will have more and more solutions. We will have more and more applications that will help us do more and more things that we either didn't do before, or will help us do things we do today in a completely different way. So the future is artificially intelligent. That family of technologies that was actually the groundwork for artificial intelligence was laid back in the 80s actually, but now we have the CPU power, we have the data, we have the storage capacity to actually do what we thought in the 80s would be the future of artificial intelligence. We're seeing a part of that right now. It hasn't reached mainstream. We'll get back to that. But artificial intelligence is a major driving force right now. And you should, like everybody, be looking for the use cases within your industry, within your company, and you will be doing that. That is happening right now. In your organization, people are looking for the use cases that will fit in your industry, in your company. And you will, as I said before, you will have a lot of experiments, and you will have some that will fail and some that will succeed and will bring you forward. Now, the future is also obsessed with data. There will be so much more data around than there used to be. And we will dive into that because that has a direct impact on your capacity need, because you need to put that data somewhere. So you need to basically get a good picture of what is your, it's pretty banal, what is your storage need in the future. And I will give you a few pointers as to where to look, because what is it that really drives a lot of data usage. So I will give you those pointers, and I will also, as I will with all the things today, I will give you some of the what we've called the scaling parameters. So what are the discrete data points that you need to collect in order to be able to make a good prognosis for infrastructure for your capacity need in the future. But data, we will have so much more data. You probably see it right now that your storage and data requirements are going upwards, going in only one direction. Well, we see a sharp increase in those requirements. Then the future is dangerous, it's uncertain, and it's risky. And like with anything in the IT world, if we have a problem, there's an IT solution to it. And there are several IT solutions to the dangerous, uncertain, and risky world of the future. So there's several tools, several technologies that will help us basically deal with that problem, with the uncertainty, with the risk that we look into in the future. Then the future is agile and composable. What does that mean? Well, it basically means that we will develop new solutions in new ways in the future. So one thing is that we've shifted from a predominantly waterfall-based project model into a more mixed model where we use both waterfall and agile methodologies in developing our new systems, our new system landscapes. So most organizations live in a kind of a mix there. Some have completely adopted the agile approach and use that for everything, even running the company, while most of our clients are in a situation where some of the programs they're running, they run agile, and others they run like traditional waterfall projects. But the fact that it's composable means that we are looking into new ways of building systems based on both components we build ourselves, but also components that are built by others. We use platform as a service, PaaS components from the hyperscalers to accelerate the build of new systems. And I'll get into a few examples during the presentation here. That changes the way we build systems, but also that we will increasingly use low-code application development platforms. So we will use new development platforms that also utilizes AI components in the construction of new systems. That will accelerate the build time for a lot of application, especially in the experimental phase. We will be able to compose new application faster. It comes with a lot of problems and a lot of issues and logins and cost and stuff that we need to deal with. That's not what we're talking about today. Today we're primarily talking about what the consequence will be on your IT budget, that we're moving in that direction. We will not touch much upon, though, the agile and composable aspect. We will talk a little bit about how that impacts your cost picture, your budget of the future. And then the future is sustainable and CO2 focused. It's carbon emission obsessed, and that the impact of that is actually works in two directions. On the one hand, this means that we will invest in all kind of technologies that will help us save energy, that will help us reduce our carbon footprint. Those solutions themselves will, of course, have a capacity and a budget impact. So it will, those solutions for energy control in large real estate, in large building complexes and so on, those kind of initiatives, they will themselves have an impact on your IT budget. But also the carbon footprint of the data center itself will be in focus. And we will try to limit the carbon footprint by utilizing technologies that basically uses less energy So there will be basically a twofold impact here. We'll use IT to save carbon elsewhere. That will require more IT. We will try to reduce the footprint of the data center itself. That will reduce cost because less energy means less cost. So they're basically working in two directions there. So those are the 5 main, in our opinion, the main areas, the main megatrends that's forming the future. And why is it important? Well, it's important because whenever we do something, we need capacity. Whenever we do something in IT, we build a system, we change the way we use a system, we move a system from one platform to another, then we need capacity. And capacity equals cost. So that's the simple reason why this is important. Now, this sounds simple. We have separate webcasts on that, just that journey there, and why it is difficult. Well, basically, the activities you'll have in your plan and in your portfolio. So you basically will have some kind of project portfolio that describes what's going to happen. Now, the interesting thing here is that there are things that's going to happen that you know about, and then there's things that's going to happen that you don't know about, either because no one knows about it, because no one's got the idea yet. But more important is that all corners of your organization, there might be people experimenting with some kind of technology right now that you don't know of, that suddenly will be an application that will go into the data center and will require massive amounts of capacity. The chances are that we live in times right now where the chances are that there are quite a few of those kind of projects right now in your organization, because the people selling all these technologies, they tend to go directly to the people whose problem they're solving, and not through some kind of IT department to get to wherever there's someone who can get his or her problem solved with this new technology. So there's probably a lot of proof of concept and pilot projects going on in the organization. And the message here is, make sure that you do spend some time trying to understand what is going on, because you need to find out what should go into your capacity prognosis, because that is the key, that you can transform your plans into prognosis. This is where most companies fail, is that they tend to forget this. They wake up one morning and a system has been developed and now needs to go into production, and that's where you start setting up the full infrastructure. It's a caricature, but usually it tends to happen quite late in the development phase that you actually size up the infrastructure that you need and put that into the budget, which is why I think all of our clients have a problem right now with predicting the real cost of IT. So one of our clients call it uplift. Uplift means that it became more expensive. Everything became more expensive than we thought it would be, and that uplift is becoming more and more of a headache for CFOs. And when we are asked to talk to CFOs, that is their number one problem with IT. That is the unpredictability of the cost picture, and it is. When we go in and make the analysis, it is partly and often primarily due to the fact that there was no good prognosis, because there was no translation of the plan into a prognosis, and basically the budget implication. So Project X requires 20 servers and 50 terabytes of storage. that equals to 1.5 million Danish kroner a year, which is also some kind of money in any organization if it wasn't part of the budget. So, going from the capacity to the prognosis, that's pretty easy. So if you look at the no, that's over here. No, it's over here. So if you look at the from circle 2 to circle 3, from capacity to cost, that is in essence a P times Q equation. So it's basically about knowing the number of units and the unit price. It is in most cases it's a number of either virtual machines or or CPU cores or whatever the unit you're using for your compute capacity, and it is a number of terabyte or petabyte of storage, and each of them will have a unit price. So basically, to be able to do this, you need to know your unit costs. It's not that difficult, and in absence of anything else, those of you with a quarterly analytics subscription can each quarter go in and see the unit prices of virtual machines and storage, which is the primary cost drivers in any capacity prognosis. So if you don't know your actual unit costs in your organization, well, this is a good place to start. Short disclaimer: if you're making a lot of AI and you're using GPUs, that's currently not part of the quarterly analytics unit price sheet. So you need to get some kind of indication of that elsewhere. Call us if you need that. We have plenty of unit prices on that as well. But capacity to cost, that's not the difficult part. The difficult part is going from activity to capacity, which requires IT and finance and procurement and sourcing to be in dialogue with the business units that's actually instigating those activities. So you need to make this work. We are moving into a future where the increase in capacity need is much bigger than it used to be. So this is more important than ever. And we are in this special period in time where we have a lot of hype around a number of technologies and a lot of investment in those technologies in companies. That means that it's going crazy right now. There's a lot more happening that makes this important. So you need to know the unit cost, have some idea. You need to know how many units you're using with your existing landscape. And then, as just above my head, develop a capacity prognosis based on a deeper understanding of the projects driving the capacity need. So that's something you need to spend some time doing. You need to ensure that you have a consistent life cycle management approach to whatever capacity you're using. You need to, here we go. You need to understand the implication of different sourcing scenarios, because you might want to source some of that capacity in-house, on-premise. Some of it you might outsource, and some of it you might put in the cloud. Now, no matter where you put it, it will cost you money. Hopefully you will put it the most cost-efficient place. There is a difference in the unit cost based on where you put your capacity and how you source it. It can be a pretty tricky and complicated calculation to make this completely right, and you need to do it right. And then obviously you need to, as we said on the last bullet here, constantly compare and benchmark different sourcing options. You need to be aware that the way you're sourcing it today might not be the way you want to source it in the future. And whenever you are considering sourcing things in a different way, especially moving in and out of the cloud, you need to be sure that you do it in a cost-efficient and generally in an efficient way. Okay, so the future is expensive. And our prediction, because we've actually helped a lot of clients calculate this, is that most clients are looking into a doubling of their capacity requirements over the next 3 to 4 years. So you should expect that your infrastructure footprint, the form might change, the proportion of cloud versus on-prem will most likely change, but the total capacity need will most probably double over the next 3 to 4 years, driven by the megatrends that we're talking about now. So it is dramatic. Okay, so just a very high level picture here, and then we'll dive into the details a little more. So the 5 megatrends I described before, the digital and artificially intelligent, the obsessed with data, the dangerous future, the agile and composable, and the sustainable future, those all have impact on cost, and they carry with them a complexity that itself, the complexity itself will drive some kind of cost, but it also drives uncertainty and risk itself. It does drive the need for competences. You will be in some areas you will be limited and inhibited by the availability of talent and so on. But there's a complexity and a cost factor. We'll of course focus on the cost factor today, and just say that AI and data will have a very high cost associated with them. That's also true for agile and composable, and we'll get back to that in a short while why that's the case. But it basically means you will consume a lot more functionality that you will pay for. You will compose application using PaaS elements that you will pay for, and you will pay a lot because you will become completely dependent on these PaaS components, and the price for those will be like any other software really. That the higher the login, the more price increases you'll see. Now, we are somewhat uncertain as to what will be the cost implication of cybersecurity. It's definitely going to be noticeable, but whether it's going to be a high or very high or medium, we think that's a bit more difficult to estimate. And when it comes to the sustainability efforts, well, the jury is still out as to what this will actually mean. So how much will we use IT for these areas? How much focus will there actually be on the carbon footprint of the data centers? It's yet to be seen. So we believe that the uncertainty here is higher than it is with especially the 2 first elements, the 2 first megatrends. Now, when we're talking megatrends, when we're talking technology trends in general, there's no way around it. We need to talk about the hype cycle and the way we get excited about new technology and what that means for the adoption of new technology. Because whenever we see something, whenever there's a technology trigger, we're excited. And that means that we talk about all the opportunities, how this can change everything. And we reach the peak of inflated expectations, where everybody believes that this is the resolution to every problem we can even think of. And all the problems we had in the past will probably be solved by this technology. And AI I just heard the former CEO of OpenAI saying that AI will solve cancer and the climate crisis, which is, I think, is a very good picture of, and no doubt that AI will play a role and does play a role in the cancer treatment advancements, no doubt about it, and no doubt that AI is part of developing new energy saving solutions that is an integral part of solving the climate crisis, no doubt. But the fact that it should basically remove cancer and solve the climate crisis all by itself is perhaps stretching it a bit. But that's a good picture of the peak of inflated expectation, where we have maximum expectations to this technology, maximum visibility. All investment dollars are moving in that direction. And what will happen, this is not only my prediction, but this is Gartner's, you could say, universal prediction for all technologies, is when we are at the peak of inflated expectation, it only goes one way. It goes down into the trough of disillusionment, and that's a good thing. This is where we'll find out what use cases will actually work. What can we actually use this technology for? The higher the peak, of course, the deeper the trough. And the more people will lose money. So I had a family member that in '98 invested a lot of money in e-commerce. Well, it turned out to be that he was investing in the right technology, but the wrong companies. So that will happen. So there will be a lot of companies going bankrupt, lots of use cases that prove not to be viable in the future. There will be a lot of disillusionment until we get to the point where we've actually sorted out what we can use the technology for, and then we can move into the slope of enlightenment and the plateau of productivity, and it becomes mainstream technology, a technology that we all use. And just to give you a short example, I mean, just where are we right now with a few technologies? Well, according to Gartner, quantum machine learning, I guess you've heard about quantum computing. No one really understands what it does. The way to explain quantum computing is to explain something inexplainable with something else that's inexplainable. Well, I admit it. I don't understand it. I'm a computer scientist. I worked with AI since the 80s. I don't understand quantum technology, not really. But cool for those who does. According to Gartner, this is a technology that we have yet to understand exactly what we can use for, and we're not even excited. We are not even really excited yet, but we will be, because there will be technology coming out there. There will be people that can explain us how it works, and it will most probably have a huge impact on security and machine learning, and will accelerate, completely change the way we do machine learning and AI. It will take a while. Now, generative AI, ChatGPT, according to Gartner, is now at the peak of inflated expectations. So right now, we are moving into a period where we'll find the use cases. So right now, there's a lot of AI going on everywhere. Now, these cars that drive themselves, well, we thought that would be an easy fix. A few years ago, we thought that autonomous vehicles would be around in a short while. Well, they won't. There's a lot of problems with these cars. It turned out that we could make cars drive themselves in like 95% of the time. The problem was the last 5% of the time, where the car is at a small road leading into a big road, and it's trying to get in. You've tried that every morning if you live in Copenhagen. You come from the small road, try to get into the big road. There's cars in long rows on the big road. What do? You do something the computer can't do. You look people in the eye and ask them, can I get in here? And they nod. And you drive your car in. Well, the autonomous vehicle can't do that yet. So there's a lot of things there's not a lot of things. There's a small number of things they can do, which is an inhibitor, which we need to solve until we get up to the plateau of productivity. So there's still a lot of work to be done. Privacy management tools, I don't know if you know of them. That's a technology that we talked about some years ago. Now they're actually getting there. And most organizations are trying to put them into their IT infrastructure. And gamification, well, gamification is a mainstream way of developing applications using game elements. So these are among the 500 technologies that Gartner is tracking. And this is just their take on AI technologies. And as you can see, there's a lot of technologies on the rise, on their way up to the peak of inflated expectation. And the generative AI, the things we're talking the most about right now, is at the very top. And perhaps most interestingly, the legend here says it's a light blue. I don't know if you can see it, but it's a light blue circle, meaning that Gartner believes, and I believe everything Gartner believes. The Gartner believes that it will take 2 to 5 years for this technology to reach mainstream. So this is happening. We will go through a period of disillusionment, but that's where we will actually mature the technology. We'll find the use cases. It will be transformative. The use cases where it actually helps us will help us a lot, and it will drive a lot of capacity need. Now, the way we build the future systems, composable, is by using these PaaS elements. And just a brief look at Azure's PaaS component landscape, well, basically tells us that it is very much about data. It's about analytics and Internet of Things. It's about intelligence, AI. That's the middle one to the right. And then, of course, a lot of development services, developer services that will allow us to build stuff faster. So the toolbox is there for the developers to basically assemble these applications pretty fast. So breaking down the cost impact. So where should you be looking for your cost in your IT organization? AI and digital, it's CPU and it's storage. It's a lot of CPU. It's actually so much CPU that the CPU manufacturers can't follow the demand in the market right now. It's a lot of storage. And obviously data will require a lot of storage. And also actually data and analytical tools that are not AI, but more standard analytical tools, they will drive a lot of CPU requirement as well. So whenever someone is peddling an AI project or data project, this is where you should be looking. You should ask them, so how much CPU, how much storage do you think this will require? Now, in many cases, the answer will be, well, we're not really sure. And I'll give you some of the good questions you can ask in a short while to try and narrow down and get to some kind of answer to these questions. Now, there's software in all of the three main trends, AI and digital, in data and in security. So there's often a quite substantial software investment and an ongoing software license cost. And those of you who've been to our webcast on software negotiations, well, software negotiations become even more important because of this. So your dependency on, say, Microsoft, SAP, SAS Institute, Oracle, that all have these kind of software solutions, well, that dependency becomes even bigger. Your the share of wallet, their share of your wallet will become bigger, and therefore the need to negotiate those kind of contracts, your software contracts, is even more important. And remember, it's easiest to negotiate the first time before you become dependent. So whenever you move from a proof of concept into the first real license contract, pay attention to that negotiation. That is the negotiation that will determine what you will be paying from now till basically you retire and the people following you retires, right? So look at your current IT budget and ask yourself, those software licenses we have in the budget right now, when did we actually start using that software? Your Microsoft Office, your SAP system, it was not yesterday, it was not 5 years ago, it was most probably 10 or 20 years ago. For your mainframe, it was 30 years ago that you actually started using that software. And today you're still paying for that software. You're paying a lot more. And that's why the first negotiation really matters. You'll spend a lot of development money on AI and digital. You'll spend some on data and some on security, but you'll spend a lot of development money on AI and digital. Governance is heavy and expensive on security. And the business side of your company will spend basically a lot of time on AI and digital, probably also a substantial amount of time on data. And surprisingly perhaps, a lot of time on security. That's because understanding and mitigating the risk picture is not only about IT, it's about a lot of other things as well. Okay, so let's take a brief look at data and what will happen with the data that you store all kinds of places, in your data center, at your outsourcer, in your SaaS solutions, by the way, and in the cloud, in different kind of clouds, you will store data. And here it's important to notice that there's some kind of data that takes up a lot more space than others, and that is graphics, pictures, videos, and we use that a lot because relational data doesn't take. I mean that relational data is basically databases with numbers and text in them. They don't take up that much place, not compared to graphics, pictures, videos. And you'll get a lot, and you think, okay, where do I get that from? Well, you'll have surveillance cameras. Security solutions that with surveillance cameras, you'll have a lot of cameras, and they will basically save the footage from those cameras. You will set up a lot of cameras in your production environment. If you're a manufacturing company or any kind of company with physical real estate where you have things going on, I mean everything else than an office. So that could be in an airport, that could be in a farm environment, that could be in a production environment, in a logistics supply chain environment. I mean, in all these places, you'll set up cameras. Why? Well, because you can suddenly make sense of the images through AI. So you can basically set up a camera and you can have technology that makes sense of what is being filmed. So you can have surveillance, and you can have, instead of having people looking at surveillance cameras and seeing for burglars coming in or unexpected things to happen, you can have machines doing that. In production, you basically exchange people looking at conveyor belts with cameras looking at conveyor belts, looking for things that are out of the ordinary. Satellite images. A lot of companies are using satellite images, and public sector entities are using satellite images for all kinds of things. So that could be basically to understand what's going on people's plots. Are we seeing more trampolines in gardens? I mean, all kinds of analysis. And drones, the kind of more close to the earth alternative to the satellite image. A lot of municipalities in Denmark are actually using drones to fly over residential areas to basically see that no new buildings are being built without permission and stuff like that. 3D scanners, scanning all kind of things for all kind of purposes. We are recording Teams meetings. We are recording small and long educational and instruction videos. We're doing webcasts like the one you're watching right now. We edit videos for SoMe, and all these graphics, pictures, and videos, we save them. And some of them will take up a lot of time, a lot of capacity. And many organizations have been surprised by the impact of different initiatives in terms of this. And I'll give you a few calculation examples in a short while. The other thing that adds to the massive amounts of new data is Internet of Things. I mean, we put sensors up everywhere, and we record massive amounts of new data. We build what we call digital twins. That is digital representation of something in the real world. It could be a car with, let's say the car has 50 sensors that records stuff in real time. And you are able to basically see the status of all those sensors in real time, but you're also saving them. I've heard that 1 hour of driving in an autonomous vehicle generates 1 terabyte of data, because it's got cameras as well. 1 terabyte of data for 1 hour driving. So just imagine if you had 100 cars driving 8 hours a day, all weekdays. It's a lot of data. We'll have energy consumption sensors when you build new houses today. There will be a lot of sensors, but they're also built into all kind of appliances that we buy. We will record weather-related data. We'll record security-related data. We will have applications of sensors in manufacturing, in agriculture, and in medical. So those are areas where we'll see a lot of new sensors. Now, just driving the argument. So if you are setting up cameras, for example, and in this example we're setting up, you can go to many calculators online. It's not that difficult, and basically do the calculation. And sometimes you get surprised. So if you put up 25 cameras that records at 25 frames per second, and you record 24 hours a day, like you would probably do with a security camera, surveillance camera, and you store the image, you store the recording for a month. So you're able to go back 1 month and look at your recording. You do that in HD, and you do not compress it. You just use the simple compression of MJPEG. Well, that will actually take up 431 terabyte of data, which is a massive amount. It's almost 1.6 million Danish kroner to store that if you store it in a regular SAN environment. And obviously you won't store it in a regular SAN environment unless you're actually using that. So if this is on a production floor and it's data that you actually want to analyze real time and retrospectively, it's probably not good enough to have it in a cold storage in Azure or AWS or Google. So you probably need storage that will cost you at least something, and you might want to do it in this resolution. Well, if you can do it in what we call H.264 resolution, it's a lot cheaper. But it's still real money, right? I mean, it's still 77,000 Danish kroner a year for these 25 cameras. So if you're putting up like 100 cameras in your production environment, this just tells you it could be extremely expensive, it could be less expensive, but still noticeable. So do the calculation whenever you do these kind of things. Now, another example that we just came around, and I have it more because it's exotic rather than it's relevant for most of you. But that's what's going on in the healthcare sector right now, is that we are doing what's called whole genome sequencing. That's an analysis of your genome. So one person delivers, I think, some kind of sample, and it goes through this elaborate process, and it ends up with a sequencing blueprint of you, basically. It takes up 300 gigabytes of data for one person. And the compute requirement for one sequencing is 2,000 CPU node hours. So that's either one CPU in 2,000 hours or 2,000 CPUs in 1 hour. You get the picture. Obviously, this is actually quite a massive capacity itself. But if you do it for 100,000 people or the entire population, it is going to be extreme amounts of compute and storage requirements, which is why we have a separate public sector entity just doing that, running a supercomputer to do that. This is AI inside the process that requires these number of CPU node hours. This is just one use case of AI. So, whenever you see the yardstick, tommelstok in Danish, it's because, and I know the layout of these. We have graphic people employed in the company. They were not responsible for this PowerPoint. But whenever you see the yardstick, it signifies that these are the scaling factors. This is what you should have under control in order to be able to estimate your capacity need. So whenever you are faced with someone using video, you should grab your capacity gun and say, hey, we need to have this under control. I need to understand how much storage this will take up. And the main drivers are the resolution. So it's extremely important whether you work in 4K, HD, or some lower resolution. It's extremely important to understand how many hours you're actually capturing. So your drones flying over or doing surveillance, or how many hours do you actually record? Whenever you have imaging, and that goes with like scanners, you have an MRI scanner lower right here. What's the image size? What's the retention? How long do you save your videos? How long do you save your images? And what's the compression algorithm? Those are the things that will determine how much time, how much space it will take up. But if you're using video in larger scale, expect this to have a massive impact. No matter how much you compress, no matter what the resolution, expect this to take up a lot of capacity. And the IoT, I talked briefly about it before, but the IoT, we're putting sensors in everywhere. The IoT is a good example. Even though it's relational data, it's so much data in a short while. So your iPhone, for example, samples all its sensors 100 times per second. So the frequency is extremely high. If you were to save everything from your iPhone, all the sensors, not including the camera, not including what's actually set in the microphone, but just whether the microphone is on or off. So the position, the gyro, the acceleration, the compass, the barometer, and how light it is around the iPhone, well, that will take up 2 terabytes per year for one iPhone. And that's just an example of sensors in use. There's other sensors are getting in everywhere, as I said before, in agriculture. We'll see it a lot in the greenhouse here. In chicken farms are filled with sensors right now, measuring all kind of things, climate, how much they eat, how much they drink, and so on. And in the production line, where you have, manufacturing is changed by the use of these technologies, and as they have made use of picture analysis, graphics analysis, so basically watching the conveyor belt, watching the what's going on in on the manufacturing line, and looking for atypical behavior and reacting to that saves massive amounts of money, but it also means that you are going to save a lot of video, because you want to be able to go back and do research on what this looked like 5 years, not 5 years ago, 5 minutes ago, 5 hours ago, last month at the same time, and so on. You want to be able to do that analysis, so you're saving those images. It will take up a lot of storage capacity. So if you are putting a IOT in place in your company, one of the things that you should go out and ask people about is to say, okay, so what's the calculation intensity? How much CPU does 1 minute or 1 hour of operation really require? And whenever there's an M here, it's something that you probably can't calculate. You need to measure that. So you basically, whenever there's an IoT proof of concept going on, make sure that people measure the capacity need for calculation. The number of sensors, well, that's a scaling parameter. Of course, the more sensors you put up, the more calculation you will have to do. The bigger the packet size of the data, the more data you need to store. So number of sensors, packet size, and frequency will allow you to basically calculate your storage need together with the retention policy. How long will you store the data? So if you have the last 4 of these, you'll be able to calculate your storage requirements for an IoT solution. And again, many of you will be surprised, because some of the sensors, being cameras, will have a huge packet size. And basically the data retention policies will be one of the most determining factors. How long do we store the data? And in some cases, you want to store the data perhaps for a year for quality assurance or audit reasons. So in many cases, you will have regulatory requirements, or at least regulatory considerations, requiring you to save data for a long time. And these are basically engines producing data on a massive scale. So the longer you save these data, the more data you will have, obviously. But these can end up being huge amounts of data, because you want to save them for a longer time. That's in essence, that is also one of the big dilemmas in IoT, is we can't save everything for a long time. That's simply impossible. Your own iPhone also throws away a lot of data. Only a part of it is actually being used, and it's being used in real time and saved for perhaps 5 or 10 minutes, and then it's been discarded by your iPhone. So retention policies apply for the technology you use every day, but in many cases you'll find that in production and manufacturing environments, that it will be that there will be a requirement for a long retention period, and therefore a huge capacity requirement. Okay, analytics is so we have all these data, we'll do several things with the data. But first of all, we'd like to make sense of the data. I mean, some of the data is just being used to control things. So in IoT, a lot of the data are just being used in application that controls the manufacturing process. It's some of the data are not even touched by humans. They're being analyzed, and things are happening as a result of that. But with a lot of data, we'd like people to be able to analyze the data, make sense of the data. And this is becoming the new thing in many organizations. As bullet point 3 here to the left says, analytics is being democratized. So we're giving analytical platforms to more and more employees. And more employees require access to analytical platforms so they can analyze on the huge amount of data that are now available in the organization. We want to make data-driven decisions. Data-driven is a new positive word. Is that instead of it's driven by feelings and emotions and beliefs and so on, we'd like more of our decisions to be driven by actually and supported by real data. And as I always, as we usually, some people used to say, never trust a piece of statistics you didn't manipulate yourself. So everybody wants to be able to basically do the analysis. And analytical tools comes in several flavors, and we make the distinctions between 4, you could say, a hierarchy of 4: descriptive analytics, diagnostic analytics, predictive and prescriptive analytics. And actually the AI component goes up. There's no real AI component in descriptive analytics. There's a certain AI component in diagnostic, and a huge AI component in predictive and prescriptive analytics. So what do? Well, descriptive analytics is where we actually test our hypothesis by cross-tabulating or visualizing the data to ourselves. Now, descriptive analytics is where most people work. They work with big data sets trying to test whether there seems to be a correlation between different parameters, looking at time series and so on. You can do a lot with descriptive analytics, and the more data you have, the more analytics you can do. The Danish Statistical Bureau has a homepage called the Data Bank, and I will advise everyone to go in there and try and do their own descriptive analytics of whatever you like. In our company, we publish internally what we call the butter index. That is the index price of butter compared to other dairy products, and then we do bets on where the price will be next month. So that's a piece of statistics you can do. You can also see statistics of all other kind of produce and scientific and social data. Descriptive analytics and the democratization of analytics is driving huge amount of capacity in organization. It's often overlooked because these are not new technologies. These are technologies you had in your company for a while. You had Click or Power BI or SAS Institute or whatever you had. You had these applications, but suddenly they will be used by more and more people. Before we had 2 people in the finance department. Next year we'll have 40 people in the finance department with access to Power BI, as one of our clients said. And then it suddenly becomes a consumer of compute capacity that's to be accounted for. So analytics, understand where the analytics is being used, and basically the scaling factors here is how intensive is the average analysis. And what you should do is basically go in and look at the use of whatever BI tool you have right now, and find out how many analysis is being made and what's the CPU usage of that. And then simply multiply with the increase in number of users. And if you expect an increase in frequency or decrease, you should factor that in. It's not that complicated. It's actually pretty simple grocery store mathematics. You need to measure the CPU intensity of what you do today, and then you just scale it up. And I promise you, you will be surprised, because the number, they do go up. And in many companies, it's not just a doubling of the number of users. It's 10 times more users given access to these kind of platforms. Okay, AI. We talked about it before. Lots of stuff going on in the AI field. And yeah, it's going crazy. Gartner says that by 2025, that's not that far away. AI will be a workforce partner for 90% of companies globally. I just need to say Microsoft Copilot, and you know what I'm talking about. It is a kind of technology, and people are just, with the insanity in their eyes, they're just craving this technology. We are seeing it right now. So, and yes, it will have an impact, no doubt, on the way we do things. But it will also require massive investments. And whether you're running these kind of AI workforce partner tools in the cloud, in Microsoft clouds, it will consume capacity and have a cost, or whether you're using it on-premise because you don't want to share all your insights and all your mails and all your PowerPoint documents with other people in some kind of form. So it will require quite massive investments in capacity locally. So be aware that this is going to happen in a pretty short while. Smart robots, yeah, we are seeing them right now in help desks and service desks. We're seeing the smart robots emerging in some areas. We'll see a lot more. It will be customer service smart robots that we will see, and we will also see physical robots over the next 8 years or 7 years, as it is here. And yeah, the last one is just to say that a lot of you will fail in your first attempt. So you'll try to build your own large language models from scratch, and it will fail. But that's the way it goes. So yeah, that's the way the humanity moves forwards. Trial and error. Yeah, I will not go into machine learning because we're running a little out of time here. So machine learning is, of course, the underlying deep learning, machine learning, all these kind of technologies. It's basically about training a model, and training the model requires a lot of compute power. We have in our office right now, we are training a model right now that on a big machine that can recognize and categorize ITSM tickets. I won't go into the details. It's a machine learning model that allows you to basically recognize different categories of calls to a help desk in order to identify where you could probably do something to optimize that help desk. It's just one out of a million use cases of machine learning, but it's quite good machine learning algorithms to actually do that. But it requires substantial amount of CPU power to train the model, and it also requires some CPU power to run the model. Some of you have seen this example before. In New York, there's a lot of cameras. You can readily get access to these 700 cameras. I think there's on Manhattan. And one of my good friends, he actually built a system just tapping into the camera that's publicly available, grabbing the pictures every 15 seconds, storing them in a local system, and then applying a machine learning algorithm that can actually recognize vehicles. So that's a Google algorithm that you can use. I think it's for free. And then he started counting cars on 700 cameras every 15 seconds, 24 hours a day. That allowed him to count cars on Manhattan, something that was never done before on this scale. Because previously you had to put people out there and counting the cars. Now, tapping onto existing technology, using readily available machine learning algorithms, he was able to basically build in a few months a system that could, for the first time, show the municipality of New York that this is the traffic intensity across the city over the day and over the week, and he could dive down and do all kinds of analysis of these data. Obviously, he was storing a lot of data. Obviously, he was building this in a composable way, but he was able to do new stuff, things that you weren't able to do before. So this is just a small example of composing new application using readily available functionality out there. Yeah. Whenever Netflix proposes you something, you know that obviously it uses machine learning because it tries to find something that you'd like to, that will most likely fit what you liked before. What you probably don't know, perhaps you don't know, perhaps you know it, is that the picture they choose is also based on your preferences. So when it find out that you most likely would like to see Stranger Things next time, there are 9 different pictures it can choose from. So the picture you will be shown is also a reflection of what kind of pictures you responded well to before. So it works in many layers already. I've taken this one just to demonstrate, to make one single point. These are the 50 most valuable companies in the world. And obviously, if you go down to the left, you see that Alphabet and Meta and Amazon and Apple and Microsoft, they take up quite a large bit of this. So these are valuable company, and they're valuable because we all expect that this is going in one direction. But there's one company that's very interesting, and that's NVIDIA. Blue box in more or less in the middle, left to Visa. NVIDIA, some of you will know NVIDIA, others won't. NVIDIA makes CPUs. So they basically make the hardware that goes into AI. These bastards. So if you have a teenager playing video games, they'll have something like this, probably next generation than the 1080. But this is a GPU. This is the heavy machinery running AI. And this is what's driving a lot of the CPU cost. That's those bad boys here, and they're in short supply right now. They're in short supply right now, but there's a lot of them being freed because they were used to mine bitcoins. So and I just read that a lot of the GPUs used to mine bitcoins will now be used for artificial intelligence. Okay, so how do you get a grip of the capacity use of AI? Well, you have to stay close to the people working you need to pay attention to the people working with the proof of concepts right now. And you need to ask them to not only check, does this model work? Is it a good model? You need to make sure that they measure the CPU and storage usage as they move along. Because you need that number, or those numbers. You need to know how many CPU hours does this require. What is the capacity footprint that we should expect? Because then, of course, the number of instances, how many different instances of your model will you implement? What's the frequency with which you will be using it? Is it a model that's used in real time every second? Or is it a model that you run once a month to find suspicious behavior? No, I don't know. So what? But it's about measuring, and the primary our conclusion here is it is measurable. You are actually able to, when you're running these models, to do that. But the people developing the models are not focused on that. More iron is more capacity is usually the answer as you are developing this. Put in another few GPUs until it actually works. But you need to have that more long-term view on this and say, okay, so how will this scale in terms of infrastructure need? Because otherwise you will be taken by surprise as a company. And yes, you can basically measure this. You should do that. The last megatrend that we should get some kind of grips on is the security and risk megatrend. How does that actually impact cost? Well, you will buy a number of services. We have a quarterly analytics article on the services that you can buy, outsourced services, security services, and they will have a price tag, and you can ask your vendor about that. There will be a lot of security built into the standard capacity supply. Supplying CPU capacity and supplying storage capacity will have increased security built in, but that will just be part of supplying infrastructure and the price associated with that. No, we're talking about the security that goes beyond that. And the general advice is, of course, as always, get a good picture of your exposure, your risk picture, implement proper mitigation measures, blah, blah, blah. That's what we talk about when we talk security. So there's a number of threats coming from different kind of stakeholders for different kind of reasons. So these are this is the map that you will be looking at. So we are looking at both employees and cyber criminals. We are looking at business partners and hostile nations that wants to do things. We're looking at hacktivists and competitors. All these kind of people can threaten us. Some of them will be more likely to threaten us than others, and it's always a good idea to go to Center for Cybersecurity and have their overall risk assessments to say, okay, where's the biggest risk right now? In many cases, it's the general risk picture right now is that cyber criminals are one of the major threats right now to many of us. Whether they're then backed by nation states that are actually utilizing them to create some kind of unrest, well, that's still open. In some cases they do, in some cases it's not. But this is the picture. And what you do in order to mitigate this is basically two things. One, on the one hand, you will be working with security awareness, making sure that you have governance and processes and education in place to make sure that everybody is aware that there could be these kind of threats, and we all should be aware and not leave our password around and not, do not click on suspicious emails and stuff like that. That's one thing. But then on the other thing, the tech fix to security. We will put all kinds of technologies in place. SIEM and SOA, security incident and events management tools, and security orchestration, automation, and, as we say, response tools. This is the big new thing. And you will be investing a lot of money in those kind of tools if you have your own data center. And your outsourcer will invest in those kind of tools, and you will have to pay for the use of these tools. Surveillance tools, threat detection tools, event management tools, increased logging, and log inspection tools. And what happens is, what you will be doing is you will set up integrations and connectors from these tools to all your applications. So you will be monitoring all kinds of transactions. This is going to be massive amounts of data, as you see just behind me. If you look at your Azure account statement, if you look at your Azure bill every month, you'll find that logging and log-related services is probably number 2 or 3, or at least number 4 on the list of items that you're paying for. You pay a lot of money for basically logging information about what you're doing. You will be logging even more. So the more integrations and connectors you put in, the more you will store. The more transaction intensity you have, I mean, the more log entries going through the pipes every second, the more you get. The total log intensity and the log size is really what's driving the cost here. So the more log files you have, the higher the cost. Also, you need to take a close look into the economics of your SIEM and SOA solutions, because they will drive a lot of cost. And basically, it's about knowing how many. I mean, the gigabyte of log files generated every day is a major cost driver here. So knowing that and knowing what the expected development in that metric is key to understanding the future pricing of your security solution, your SIEM and SOA solutions, which is going to be among the biggest. And obviously also the storage consumed by the log files themselves, and how long you save the log files. But there, the log files are basically just data and covered by what we talked about earlier, the retention, the intensity, and so on. So that is covered by what we've talked about earlier. So with that, we've reached the end of this presentation, and I hope that the yardstick slides gave you a bit of a picture of what intelligent questions you could ask to the people running the projects that will most likely lead to a substantial increase in your capacity need in the future. And it is very much about the process of actually doing that, asking the questions, understanding what is the result of the activity on the capacity, and thereby on the financial and the costs. So thank you for your participation today, and I hope to see you soon on a webcast here at Zangenberg. Thank you very much.